And welcome to today's video. Today we're going to be doing 1089 maximum number of balloons. So given a string of text, you want the characters of text to form as many instances of the word balloon as possible. And you want to use each character in the text the most once, and you can do the maximum number of instances that can be formed. Okay. Okay, that makes sense. Well, what I'm thinking of is having basically we can create a counter hash map. Characters as text to form as many instances of the words balloon as possible. Yeah, okay. So, my idea is to have basically a counter hash map containing... Yeah, so basically a counter hash map containing something similar to this. So we have B, A, L, L, we need a double one, O, and then N. Now for this one, basically what we want to do is we want to check to see whether or not how many characters exist for each one. So let's say for this one, we basically go through all of these, and then if it's if it's a key inside this, so if it's one of these characters, then we can go ahead and increment it by 1. So then we can go like 1 like this. Same thing with this one, we can increment it by 1 if it exists, etc, etc. This becomes like, let's say like there's 2 of these, so it becomes 2, so on and so forth. Eventually at the very ends, what we can do is we can loop through it, the hash map, and check to see whether or not the values, like LL over here, OO over here, are equal to what's acquired. And what's acquired for balloons? Well, you need 2 L's and 2 O's, so we need to check to see how many are valid for that. Same thing with the ones in the A's and the B's in the A's. So basically just keep count of all the different characters and add it to this hash map, and then check to see how many can be fulfilled at the very end, pretty much. So how many fulfillments of balloon could be done given the count that there is. So yeah, I can go ahead and begin implementing this now. So we'll have basically loop through, create a hash map. Or, yeah. Actually, first thing, what we can do is we can actually have a counter instead. So we can do a balloon map or text map, and we'll have this to be equal to a counter of text. Oops. Given this counter, what we can do is we can check. It'll basically return a count of all the different numbers which you're gonna get inside the different examples, and then given that, what we can do is we can then loop through and check to see, subtracting the values, how many balloon counts we can get. So we'll have balloon count equals 0, and then what we'll do is we'll have a balloon count to see how many we need. So basically what we're going to do, so for value, the character we're trying to find in, for value in this, so B, A, L, L, O, N. What we want to do is we want to see if the value exists in the hash map. So return, actually, so if value in text map, then you want to effectively remove it. So you want to decrement it. So we'll do text step v minus equals 1. We want to subtract it by 1, and then we want to check to see if it's 0. Yeah, and then we check to see if text map value is equal to 0. If it is equal to 0, then we want to return false because we need it. Well, you actually just want to... Yeah, you can't form a balloon from here. So then you just want to return the final count. Yeah. So otherwise, what we want to do for v in value, if it's in text map and if it's equal to 0, we want to return the balloon count. Otherwise, you just want to subtract from the text map by 1 until it is equal to 0. And then if it makes it through all of this, for all of the values, oh sorry, just gotta add another O. If you make it through all of the values, then you can return, and you can add increment balloon count by 1. So start off, literally through every character, check to see if the value is in text map. If it's equal to 0, if it's equal to 0, we want to, if it's equal to 0, we want to return the balloon count. Otherwise, we want to keep going until we reach that point. And actually, we want this to happen basically while the and at the very end, if we make it to n, if v is equal to n, and at the very end we can increment the balloon counts, because that means that we've been able to do one instance at the very end. Yeah. So we'll loop basically what's happening, instantiates a counter of the different elements. It loops through for every single character, checks to see if it's in the text map. If it's in the text map but it's equal to 0, then we just return balloon count because we can't contain any more possible combinations. Otherwise, we just subtract the text map with the value by 1, and we keep going. And if it's equal to end, we've reached the end of the sequence, and then we can go ahead and increment the balloon count by 1 before returning that final value. So if you go ahead and run this, okay, case 2, output's 1, but we should return 2. 0, 1, okay. Okay, let's see what happens. BALLOON. Yeah. Oh, and you can use the character in the text at most once. Yeah, that makes sense. Counter. And then... Yeah. Oh, we actually want to loop through this again over and over again. So instead of doing that, we can do while there is values in the text map still. So while the values are non-zero, we can just do while true, and then we can do balloon count plus equals 1, and then we can do a check to see if this ever happens, if it's equal to 0, then we just return the balloon count. So it'll just keep looping through infinitely until we do it. So this will work for numbers beyond 1 as well. Yep. Do a quick run through of this. Output is 1 when you expect a 0. If v is in the text map, then we want to subtract it by 1. Oh, we also need to have a check to see. Yeah, if it's equal to 0, then we return balloon count. Otherwise, we keep going. It should stop at B. At B, if it's not on text map, then it should not be found. Oh! Yeah, we need to have a case where, if there isn't any value, then you just return that. Oh, yeah. Okay, yeah, accepted. Time for this one. It's going to be O of n. So first, O of n, where n represents the number of elements, characters in the text. So that's going to be for the initializing the text map. And then for this one, for all of that, yeah, it'll be O of n. And then it'll also be another, yeah, it should be O of n. And then you're looping through basically every single character again, over and over and over again, in order to check to see whether or not it's equal to the balloon, but the overall complexity should remain O of n. Just go ahead and verify this. Yeah. Nice. Yeah, and space complexity is O of n because you're storing it in the counter. Thanks for watching.